This is a short video to explain how to use the main features of the data analysis tool for playback of recorded spectra. I'll start at the top of the main form. There are some checkboxes here that enable various traces to be seen, and the markers, which I'll leave off for now. In the right panel you can select the sample frequency at which the power versus range data are played back. In the left panel, so we're at 900.0 megahertz here. There's a, moving across to the top left, there's a radio group that selects the display. We have a spectrum only display. There's a reset and a refresh buttons in the middle here to refresh the screen. And then there's a range only view. On the right here there are controls that relate to the spectrum analyzer configuration. Only some of them are adjustable. The dynamic range and the reference level are adjustable. The others are set according to what was recorded from the spectrum analyzer. So we can adjust these up and down for better viewing. And there's a long range position slider and a short range position slider, so you can zoom in on bits of the data. I'll set this back to 120 meters, which is as far as we have data here. Across the top also there's a radio group that selects the frequency band. There are 5 bands, and you only have data for some of them, like the 900 megahertz band and the multi-carrier band. For each band there's a combo box underneath that allows the user to select which data set to play back. Again, not all the data sets, I didn't leave you with all the data sets, but you have some, including a flat test range. Now toward the bottom we have a slider which allows you to select the range at which the spectra are played back, and there's controls at the very bottom to allow the user to set the parameters that are used to calculate the predicted power, which is the yellow curve here. So by adjusting these we get a different effect. Let's turn these back on. There's also a button called Config Auxiliary Scatterers, which looks like this. There's an option to include a second scatterer or a backwall scatterer, and some controls which are pretty self-explanatory. If we go to the dismiss this and go to the multi-carrier case, the first one that comes up, the first data set that comes up, is the hill fence configuration that I mentioned. We talked about at length. Now here we see, let's go back to the power and range option, and the screen's white, so let's reset the records and refresh to get back to black. You can auto scale the power versus frequency or power versus range by clicking this checkbox here. If you keep it checked and then try to adjust these controls, you get an error message saying it's disabled. So just uncheck it again, and now you can adjust the dynamic range as you like. We need to reselect the frequency. If you click on this one time and set a step size and then use the increment, it'll automatically select the carriers according to whatever step you set here. So here we are at 900 megahertz, and we can go back to the range only position and blacken that up and change the dynamic range. The blue trace is the difference between the peak power and the minimum power that was recorded at each range. And there's a little radio group at the top here called high-low. The first position is absolute, so it shows you absolute highest and absolute lowest, but you can also select drop high-low, which drops the highest and drops the lowest power recorded at each range. Some data sets it makes a difference, but largely it doesn't. If we can hit Configure Auxiliary Scatterers, there's a button, a context sensitive button, Configure for Hill and Fence under Include Auxiliary Scatterer. If we click that, and let's take out the forward scatter for the time being. Here we are. And if we click the Configure for Hill Fence, these controls automatically are set to the best fit for the hill fence configuration. A distance from the fence of 8.6 meters, copper or metal, reflecting surface, horizontal polarization with isotropic radiation patterns. And the fit looks like this. Now the range is only flat out to about 40 meters, so if we zoom in on down to about 35 or 40 meters, and again adjust the the dynamic range, we turn off the high-low and turn on the markers, we can get an idea of the fit between predicted and measured powers. Now we can step through the various frequencies and see what we see. And I think that pretty much covers the explanation.